In this how-to, we are going to point out the main steps to follow in order to achieve good hair simulation in two of the main 3D modeling software, Blender and Maya. So let's start with Blender Internal, the basic engine for Blender. After the setup of lights and cameras, we are going to create a simple furball using the particle tab and creating a hair particle system. The main parameters to set, besides length and number of strands, are random in render tab, children, and gravity in field weights. These values are a good compromise, giving us fair results. After setting a simple material, this is a first static render of our furball. Another important set of parameters is the friction after enabling hair dynamics. With a bit of tuning and a simple animation, this is the result. So let's make a step further, and let's deal with hairy head. Using this cute and creepy head, we have to paint it in order to set the weight of each vertex. After this phase, we have to prepare a natural look for the hair, combing, cutting and puffing it. Let's go to hair dynamics and tune again the parameters. This panel is very useful for the final render. Here we can see the result, with and without strand render and B-spline. With a simple animation, the final result is this. Blender internal render without any samples issue is very fast in rendering, giving fair results only after long parameter tuning. With Cycle Engine, a lot of things change. First of all, it's not straightforward to compare results, as Cycles requires some changes in the initial settings, ambient occlusion, lights and materials change. In order to use a dedicated hair feature of Cycles, we have to enable Experimental in the render panel. This gives us the opportunity to sum up all the important parameters in this panel. This is a result obtained without setting a good material. Speaking of which, the node editor plays an important role here. This node configuration allows us to achieve very good results in terms of photorealism. Even this feature is available only in experimental mode. This is the final result. As we can see, besides the improvement in terms of photorealism, even the collisions are slightly more accurate. Cycles results are way better than internal engine 1. But this has a cost in terms of time. To make an accurate hair simulation, Maya provides the N-Hair tool that produces a certain number of follicles all over the selected geometry. Each of them is gonna be editable globally or independently from the others. We can distinguish between active and passive follicles. The active ones have their own dynamic and are linked to the main control curves. Each curve controls all the hair going out from the correspondent follicle. The passive ones don't have their own dynamic, but just follow the active ones. First of all, we have to isolate the scalp, so that the hair will be around the scalp area and not all over the face or body. Then, we can add the hair system and tune its clump parameters in order to achieve the desired shape. Some are hair per clump, clump width, clump twist and clump width scale. The next step is to apply a passive collider to the mesh, from the End Mesh menu, to avoid hair cutting through the edges and faces of the geometry. We can manage both collision and self-collision by adjusting some parameters, as collision thickness, collision offset, friction and thickness. If we add some dynamic forces as wind, we can go back to the hair system menu and tune some dynamic dependent parameters as stretch resistance, mass or turbulence. To reduce baldness, we can paint some passive follicles all over the scalp and then adjust the number of hair per clumps so as not to slow down the simulation too much. This dynamic system is the core of both fur and hair simulation. Let's now set the rendering parameters to manage features as diffuse color, specular sharpness, opacity and length. Let's take a look at the results rendered with Maya software. They are comparable to those achieved with Blender Cycles, but the rendering time is much shorter. To use the Mental Ray rendering engine, we have to load its plugin and select it from the Render Setting menu. Here we can see that there are lots of features and parameters to play around with, allowing to achieve more photorealistic results. It is clear to see how Mental Ray is better than Maya software in shadow management, even though this badly affects the rendering time.